Hello students, today we are discussing about the language of chemistry. First, this is the valency, the number of hydrogen atoms which can combine with or displace. The number one atom of the element or radical so as to form a compound. Number 2, the valency of all metals and hydrogen is considered positive. Number 3, the valency of all non-metals or groups of non-metals is taken as negative. Here, some combining atom, then its product form and the valency of elements. One atom of hydrogen combining with one atom of chlorine. So they form hydrogen chloride. So this hydrogen chloride is the product and its valency of elements chlorine is 1. Next, two atom of hydrogen combining with one atom of oxygen, they form water. So this is the water, H2O. In its oxygen valency 2. Then third point, three atom of hydrogen combining with one atom of nitrogen. So then form the ammonia, NH3. In its nitrogen valency 3. So valency of a metal is the number of electron lost per atom of the metal. For example, potassium lost 1 electron, so then K1 plus is the univalent. Magnesium lost 2 electrons, then magnesium 2 plus divalent. Aluminium lost 3 electrons, Al3 plus, so this is the trivalent. Then again, valency of a non-metal is the number of electrons gained per atom of the non-metal. For example, chlorine gained 1 electrons, so then Cl1 minus, so this is the univalent. Sulfur gained 2 electrons, so then S2 minus, so this is the divalent. Again, nitrogen gained 3 electrons, so then N3 minus, so it is the trivalent. The next, variable valency. Certain metals exhibit more than one valency, so hence showing variable valency. Reason: an atom of an element can sometimes lose more electron than are present in its valence cell. That is, loss from penultimate. What is the penultimate? That is the last but one shell, and hence exhibit more than one. Or variable valency. For example, cuprous Cu1 plus and cupric Cu2 plus. Here, copper, its symbol Cu, atomic number 29. Electronic configuration 2, 8, 18, 1. In the outermost orbit, 1 electrons. So the outermost shell has and 1 electron. So this is the outermost shell and this is the 1 electrons. And the penultimate shell contains 18 electrons. So this electron is the penultimate shell and then 18 electrons. It means before outer shell. That is the penultimate shell. So the penultimate shell has not attained stability and one or more electrons sometimes jump to the outermost shell, so thereby increasing the valence electron. So hence the atom has new configuration, and this new configuration is 2, 8, 17, 2. Here 2, 8, 18, 1. But here 2, 8, 17, 2. It means this penultimate shell not attain stability. So then it is jump, 1 electron jump. So configuration is new, 2, 8, 17, 2. So therefore copper exhibits Cu1 plus and Cu2 plus valency. Next, penultimate shell. The shell inner to outermost is called penultimate shell. In this structure or this cell is called the penultimate shell. Anti-penultimate shell. One inner to penultimate cell is called anti-penultimate cell. Valence shell. The outermost shell with electrons is called valence shell. So here outermost electron is 1. So this is the valence shell. But here outermost electron 2. So this 2 is the valence shell. Then next, radicals. A radical is a group of atoms of elements that behaves like a single unit and show a valency. So radical two types, positive radicals and negative radicals. Positive radical, for example, ammonium NH4 1 plus, and negative radicals, for example, hydroxide OH 1 minus. So this is the positive and negative radical. Chemical formula. A molecule of a substance. That substance is the element or compound. Could be represented by symbol. That representation known as chemical formula. For example, sodium carbonate. It represents Na2CO3. So Na2CO3 is the chemical formula of sodium carbonate. Then next, sodium chloride. Its symbol NaCl. So NaCl represents the chemical formula of sodium chloride. Then some valency chart, that is the positive ions or radicals. Valency 1, that is the monovalent element. For example, potassium, sodium, lithium, hydrogen, ammonium. All are monovalent. K1 plus, Na1 plus, lithium Li1 plus, hydrogen H1 plus, ammonium NH4 1 plus. So all are monovalent elements. Some are variable valency. For example, cuprous, that is the copper 1, Cu1 plus. Second, argentus, that is the silver 1, that is the Ag1 plus. Next, mercurous, mercury 1, that is the Hg1 plus. Next, orus, gold 1, that is the Au1 plus. So some are the variable valency. Then valency 2. It is also called the divalent elements. Here calcium, magnesium, zinc, barium, nickel, cobalt, uranium. So calcium, its valency 2 plus. That is divalence. Magnesium Mg 2 plus. Zinc Zn 2 plus. Barium Ba 2 plus. Nickel Ni 2 plus. Cobalt Co 2 plus. Uranium U 2 plus. So all are divalent elements because its valency 2. But some are variable valency. Cupric, copper 2, Cu2 plus. Argentic, silver 2, that is the silver 2 plus. Mercuric, mercury 2, so that is the Hg2 plus. Ferrous, iron 2. So that is the Fa2 plus. Plumbus, lead 2. So that is the Pb2 plus. Stannous, tin 2. That is the Sn2 plus. And last, platinous, that is the platinum 2. So Pt2 plus. So all are the variable valency. This is the valency 3. It is also called the trivalent elements. Aluminium Al3 plus, the trivalent elements. Chromium Cr3 plus, trivalent elements. So its valency is 3. Next, variable valency. Ferric iron 3, Fe3 plus. Auric gold 3, Or3 plus. So these are the variable valency. Valency 4. So that is the tetravalent elements. For variable valencies. Plumbic lead 4, Bv4 plus. Stannic tin 4, that is the Sn4 plus. Platinic, that is the platinum 4, Bt4 plus. Manganics, manganese 4, that is the Mn4 plus. So all are the variable valencies. So this is the positive ions. The next, negative ions or radicals. Valency 1. It is the monovalent element, but these are the negative ions. For example, chloride Cl 1 minus. Chlorate ClO3 1 minus. Hypochlorite ClO 1 oxygen. So that is the 1 minus. Hypochlorite ClO 1 minus. So its valency 1. Bromide Br 1 minus. Iodide I 1 minus. Hydroxide OH 1 minus. Nitrite NO2 1 minus. Nitrate NO3 1 minus. So all are the monovalent negative ions. The next, hydrogen carbonate or bicarbonate HCO3 1 minus. Aluminate AlO2 1 minus. Permanganate MnO4 1 minus. So all are univalent negative ion. Then valency 2. It is also called the divalent element, and these divalent elements negative ions. Sulfite SO3 2 minus. So divalent negative ions. Sulfate SO4 2 minus. So divalent negative ion. Sulfite S2 minus. So that is the divalent negative ion. Then valency 3. It is also called the trivalent elements. Phosphate PO4 3 minus. So this is the trivalent. Nitrite N3 minus, trivalent negative ions. Phosphite PO3 3 minus, trivalent negative ions. Valency 4, tetravalent elements. So if the valency 4, so it is also called the tetravalent elements. Carbide C4 minus. So that is the 4 minus, tetravalent negative ions. So this is the last part of the radical. So the next video we are discuss about compounds and its property with different type of chemical formula. Thank you. Okay, students.